Hey, what's up? It's your old pal, Mr. Cook, and we made it to the end of the semester. So here is my video going over the open-ended final exam review. Now, make sure you have your calculator out. I'm not going to show a lot of work on this because a lot of it just can be done in your calculator. So, we'll make our way through this. I'll probably do like a couple problems for each video because there's 56 of them. Now, you got to also bear in mind that this is going to be a multiple choice test. So this isn't exactly how the test is going to look. It's probably going to be a little bit easier because, with multiple choice tests, spoiler alert, one of the multiple choice responses is the right answer, So like, it's a lot easier to do those. So I'll just spend time working on this, but again, I'm going to do a lot of my work on my calculator. So I'll try and slow it down when I'm working on the calculator, just to show you kind of the little tricks that you can do to answer a lot of this. So first off, like if I have functions like polynomials and I need to find values, all I have to do is plug them in, right? And if I have to plug in a bunch of answers like 3 and -2 to this, like one trick that you can do with your calculator is, just type in the equation into y equals, and then, just like find the value. So, use your table or whatever. So like if I have to do 3x to the 4th power minus 2x to the 3rd power, and then plus x to the 2nd power, and then minus 2. If you just go to your table, you can find the values. So like h of 3 is, if I plug in 3 for x, what do I get? Looks like the answer is going to be 196. So that's 196. Then if I need to find the answer for -2, I just scroll up to -2, and there it is, 66. So those are, two quick ones. The next question involves composite functions. So what this says is that I'm taking the g function and I'm plugging it into the x value into the f function. So like g of x is the input. So this is the input and it goes in for x. So if I just plug it in, I get 1/4 parentheses, and then instead of x, I put that whole thing, 4x plus 1, and then -1 at the very end. And then, I just evaluate it. So subtract the 1 from there and I get 1/4 of 4x, and then 1/4 of 4 is 1, so I just get x for my answer. All right, so this one, it's kind of the same thing, but we're plugging in g of -4. Well, what is g of -4? It's kind of combining these two problems, number 1 and number 2. First, find g of -4. So, here's the g function, plug in -4. -4 minus 4 is -8. Okay, so that means that this is really saying f of -8. So plug in -8 to this one, and we get our answer. So, you can just type that in because it's only one problem, one answer that you're trying to plug in. So we do 3 times -8 to the 2nd power minus 2 times -8, and then plus 1. And you get your answer, 209. So 209 is our answer for this one. Okay, moving on. For this function, find the following. So this one says I'm adding the two functions together. So I have 2x plus 5 plus x squared minus 3x plus 1. And then, just combine like terms because the plus doesn't do anything, to the signs on this. So 2x and -3x gives me a -1x. 5 and 1 makes 6. And then I have that x squared. So x squared minus 1x plus 6 should be my answer. Same thing, but now we're subtracting. So we have the g function, which is x squared minus 3x plus 1, minus the f function, which is 2x plus 5. Now this negative will distribute to the 2 and the 5, so I get x squared minus 3x plus 1 minus 2x, and then minus 5. Now combine like terms, and you get your answer, x squared minus 5x, and then 1 minus 5 is -4. So there's our answer for that one. Okay, moving on. Find the domain of the following. Well, when you have a rational function, the domain restrictions that you have are that the bottom part can't be equal to 0. So x squared cannot be equal to, I'm sorry, I skipped ahead a little bit there. X squared minus 9 cannot be equal to 0. So if I add 9 to both sides, I get x squared cannot be equal to 9. and if I take the square root of both sides, x squared cannot be equal to 3 or negative 3. Because remember, when you take the square root of a squared variable, you have the plus or minus in front of there. For a radical expression, the inside part just can't be negative. So we just take 7x minus 35 and say that it has to be greater than or equal to 0 and solve for x. Add 35 to both sides, divide by 7, and you get your domain. X has to be greater than or equal to positive 5. And then if you combine these two ideas, so x can't be equal to 0 and x has to be positive now, just not non-negative. So if it can't be 0, it can't be non-negative, it can't be negative, then that means that this 7 minus x has to just strictly be greater than 0. So it's just combining these two ideas. Like, this is it has to be greater than or equal to 0, and then this says it can't be 0 either. So it just knocks off that equal to sign there. And then we just solve for x, so add x to both sides, and you get 7 is greater than x. There's your domain for that one. So 3 quick domains, and we're done with the first 5 problems. Describe the transformations. So all transformations go like this, f of x, and then if you, wait, let me start that over. Y has to be equal to, and then the transformations are like this. You can have an a value in front of your function. It won't necessarily be square root. I got to stop just looking at the problem. All right, so f of whatever your function is, and then it'd be like x, and then you'd have some value that you're adding or subtracting inside, and then some value that you're subtracting or adding outside the parentheses or outside the function. The a value. Now, if a is positive, if a is negative, then it has a reflection over the x-axis. So that's what that negative tells me that's going to happen. So it has a reflection over x-axis. And, this one has a negative also, so that's also going to have a reflection over the x-axis. Okay, and then if a is, regardless of its sign, if it's greater than 1, then that means that it's going to be a vertical stretch. So since 4 is greater than 1, we have a vertical stretch. And then if it's between 0 and 1, then that means it's going to have a vertical compression. So 1/8 is between 0 and 1, so it has a vertical compression. If this h value is positive, it moves to the left. So that means it moves to the left 2 here. And since it's negative, it moves to the right, so it's moving to the right 3 in here. And then if it's adding or subtracting outside of the function, it's moving it up or down. Negative means down, so down 5. Positive means up, so up 7. So those are both of those problems for the price of 1. Write an equation for the given graph. So this graph is obviously a parabola. So it's going to be, like this thing, y equals a f of x plus h plus k. Well, the function itself is going to be x squared. So this function is going to be squared. And then the graph is moved from its original place, because usually it looks like this. The graph has been, moved over to the left by 2 and then down 1. So left 2 means that it's going to be adding 2 inside the parentheses, and then down 1 means it's going to be subtracting 1 over here. And then also it's shifted, it's moving downward, so it's reflecting over the x-axis, so we're going to have a negative out front. And then from there, it actually doesn't look like it has a vertical compression or vertical stretch, so we can just leave it as is. So for all of these, we have a bunch of these problems on multiple choice, and I'll show you even easier ways to get through these when we have multiple choice. So this is fine for going over the concepts, like this video and this review. But if you want a real good idea of what to do for the final exam and some of the shortcuts that you can do, go consult the multiple choice one. Anyways, all right, so graph the following. So let's just do a really little basic graph on this. So it's a cubic function. The whole graph has been shifted down 4, 1, 2, 3, 4. And then also it's moved to the left 1, so over 1. So right there is where it starts. And then it's a cubic function, so it goes up 1 over 1, and then up 2 over 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then left 1, down 1. And then left 2, down 8. I'm not going to get to there, but that's basically how the graph's going to look. Another thing you can do is graph it out on your calculator and look at it. All right, last thing we're going to cover on this video is even, odd, or neither. So what you do for these ones is you plug in negative x for all of the x values and see if the graph has stayed the same. If it stays the same after you evaluate it with the negatives, it's even. If the graph signs, all the signs have changed, it's odd. And if neither of those things have happened, then it's neither. So let's plug in negative x to this one. So we have 16, negative x to the fifth, minus 8, negative x to the third, plus 4, negative x, plus 2. All right, so the negative to the fifth moves a negative out front, so we get negative 16x to the fifth. The negative here to the third moves the negative out front, so plus 8x to the third. The negative here moves the negative to the front, so minus 4x, and then we have plus 2. So look at the functions. All right, so the first function, the one we started with, the 16x to the fifth, the sign changes. The negative 8x to the third, the sign changes. The 4x sign changes, but the 2 stays the same. For it to be odd, for all the signs to change, every one of the signs change. But look, we have a plus 2 here and a plus 2 here, so this is going to be neither. Now let's take a look at this. When we plug in negative x, we get negative x to the fifth, minus 7, negative x to the third, minus 23, negative x. So negative x to the fifth, the negative moves to the front because it's an odd power. So negative x to the fifth. Negative x to the third, it's an odd power, so the negative goes to the front, so plus 7x to the third. Negative times a negative is a positive, so plus 23x. And if you notice, the signs for all of these have changed, so this is an odd function. All right, now for the last one. So plug in negative x, 6, negative x to the fourth, minus 3, negative x to the second, plus 1. So when you have a negative and you raise it to an even power, it just stays, just reverts back to positive, so it'll be 6x to the fourth, minus, and the same rule applies here, 3x squared plus 1. The functions stay the exact same, so that means that this is an even function. Okay, that's even and odd functions. All this stuff can be found. Let me look. Yeah, transformations. All this is just stuff in unit 1. So if you need to dig a little deeper in this, just go back to those unit 1, the group work videos and all that kind of stuff and kind of review that. Okay, so that's it for the first page. On the next video, we'll move on to the second page. So see you then.